Hello, students. Today we're going to be working on notes 28. This is elimination by multiplication. So you'll see that the problems will resemble what we did with the last lesson as we stacked up the two equations in the system. And when we added the two equations, we were able to eliminate one of the variables. This lesson will require us to do an extra step. We're going to have to either multiply one of the equations or both equations so that we force a variable to cancel if needed. And so I'm going to go ahead and proceed to the examples following the steps as they're listed in your notes. So example number 1, I have negative 2x plus 15y equals negative 32. And then 7x minus 5y equals 17. So as I look at these two equations, I cannot eliminate either the x or the y as they are right now. But as I study the numbers, it looks like the y's would take the least amount of work because I could multiply my bottom equation so that I could make the 5 be negative 15. I could multiply my equation by 3, and that would give me a negative 15y, which when I add it to positive 15y would cancel out. So my goal is to get the same number as the other equation has for that variable, but the opposite sign. And so multiplying my bottom equation by 3, I'm going to put that in the area that I have space for in step 1, but I am going to leave space to recopy the top equation. So my bottom equation, 3 times 7x, will be 21x. 3 times negative 5y, I'm just distributing, will be negative 15y equals, and then 3 times 17, and that is 51. I'm going to recopy my top equation stacked up with my variables lined up along with my equal sign. And I think it is good to have those two equations right beside each other, stacked up so that your eyes can see what is happening. As we are adding the two equations, what we created happened. The 15y and the negative 15y cancel each other out. So we'll add and get negative 2x plus 21x. That gives us 19x, and that equals, and then we'll add the 51 and the negative 32, and that is 19. And so we can divide both sides by 19 and have our first variable solved for. It's x equals 1. Now, just like we did in the previous day's lesson, so this should now begin to be review for you. We're going to substitute our value that we found into one of the two equations. So I will substitute into the top one. It does not matter. So I'm just rewriting it here so that I can see it better as I make my substitution. So I'll be doing negative 2 times, I'm going to substitute in the 1 that I found for x, and then I'll have plus 15y equals negative 32. And so now it's just a matter of working this out. So negative 2 times 1 is negative 2, plus 15y equals negative 32. I will need to add 2 to both sides of the equal sign, giving me 15y equals, and then negative 32 plus 2 is negative 30. And then I can divide by 15 on both sides of the equal sign to get y equals negative 2. Remember that your answer should be written as an ordered pair. So we'll put the x value first, 1, and the y value negative 2. Remember that you can always check your solution through substituting into the original problem, or you can graph your two equations, and these two equations would intersect at the ordered pair 1, negative 2. All right, I'm going to move on with example 2. In this example, you have 2x plus 5y equals negative 4, and then 3x minus 4y equals 17. So as I look at those two equations, I can't multiply just one of the equations. For example, if I multiply the 2 that has the x, I can't multiply the 2 by anything to make that become negative 3. And likewise, I can't multiply the negative 4 by anything to make it become a 5. And so I'm going to have to multiply both equations. Again, it will not matter which variable is eliminated, but I do see that I already have opposite signs for my y values. I have a positive and I have a negative. So I'm going to go ahead and try to eliminate my y's. And so I have to think, what is a number that both 5 and negative 4 would divide into? And that number is 20. So if I take 4 times 5, I will get 20. So I'm going to take that top equation and multiply everything by 4. Again, distributing. So 4 times 2x is 8x. 4 times positive 5y is positive 20y. Then our equal sign. And then 4 times negative 4 is negative 16. Then we'll take the bottom equation. Now I'm trying to get negative 20. So negative 4 times 5 would give me negative 20. And so I'll distribute 5 times 3x is 15x. 5 times negative 4y is negative 20y. Notice how I'm careful to keep things lined up. And then 5 times 17 is 85. And so now we will add our two equations, and notice that 20y and negative 20y cancel each other out. So adding 8x and 15x, we get 23x, and then our equal sign, and then taking 85 and negative 16, when we combine those, we get 69. We will divide both sides by 23, and x will equal a positive 3. So there's your first solution. We have x equals 3. Now you're going to take your answer and substitute it. And really, you can substitute it into any of the equations. I, again, am going to use the top equation. So 2x plus 5y equals negative 4. And then I'll take my 3 and substitute that in place of the x. So I have 2. I'm going to substitute in my 3 in place of the x. That's from here. And then recopy the rest of the equation. Plus 5y equals negative 4. And now I have this equation to solve. So 2 times 3, that gives me 6 plus 5y equaling negative 4. I can subtract 6 from both sides of the equal sign. So this will cancel. That will give me 5y equals, and negative 4 and negative 6 combine to give me negative 10. And then finally dividing by 5, I get y equals negative 2. And so my ordered pair solution is, with the x first, 3, and the y, negative 2. And All right, so moving on to example 3. In example 3, we have x plus 4y equals 3, and then 5x plus 20y equals 15. So I'm thinking about eliminating the x. Since I haven't done that yet, I could multiply my top equation by -5. If I do that, then I would have -5x, and my bottom equation has +5x, and my x's would eliminate. So I'll do that multiplication. I'm going to multiply to eliminate the x. Multiply my top equation by -5. So distributing, I would have -5x, and then -5 times 4y would be -20y. And then -5 times 3, after my equal sign, I'll have -15. I'm going to stack up underneath that the original second equation. So that was +5x plus 20y equals 15. Now, at this point, I hope you're noticing something, and that is that everything has the same number, same coefficient in front of your variable, but opposite signs. So not only do my x's cancel as I wanted them to, but my y's also cancel. Now, I need something on this left-hand side of the equal sign. So yes, these also cancel, but I can't just lose this side of the equal sign, so I'm going to put 0 equals, and then I'll add my two numbers over here. Well, they also cancel, but I'm going to think of this as addition. So 15 and -15 add up to 0. Now, this is a true statement, and as we have seen before, when this happens, when you have all of your variables canceling out, then if you have a true statement, your solution would be infinitely many solutions. So infinitely many solutions. If we were graphing this, the graph would end up being the same line. They would intersect at every point. If we would have gotten a false statement, then instead of infinitely many solutions, the answer would have been no solution. All right, and so that's example 3, and we're ready to move on to our example 4. And this one's going to take up a little bit more space, so as I do the problem, I'll have to scroll through and see if I can fit more of that on. In fact, let me see if I can do that before I start. Yes, I can fit just a little bit more of that on the screen. So with this problem, I'll scroll up and read it. It says, tickets to a movie cost $7.25 for adults and $5.50 for students. A group of friends purchased 8 tickets for $52.75. How many adult tickets and student tickets were purchased? So after reading the problem, I like for you to find the question. So the first question is, how many adult tickets were purchased? And so I'm going to just use X. You could use an A if you wanted to. So X equals the number of adult tickets. And you want to be sure that you describe what it is that you're finding. And you can do that many, many times just by finding the question. So then the next question is, how many student tickets were purchased? So we'll use Y to represent the number of student tickets. And then we will go back and look at the questions, or excuse me, the statements in the reading. So it says, first of all, tickets to a movie cost $7.25 for adults and $5.50 for students. And then you'll see that we have a total cost here of $52.75. So as I set up equations like this, oftentimes there is an equation that has all the money values in it. So the $7.25 that we have for adults, that would be multiplied by your number of adult tickets. And then we would add to that, so we're getting a total, that each student ticket is $5.50. So $5.50 for each student ticket. So that has to be multiplied by Y. And that'll equal then your total amount of money. So that total amount of money was given to us as $52.75. So again, you have this equation that has all the money in it. And then you'll have a second equation that is usually about a count of items. So either a count or a number of items. And as we look at that, it says that we have a total of this group of friends bought 8 tickets. And so some of the tickets were adult, some of the tickets were student, but there were 8 total. So we'll have equaling 8. Now, if you're just counting the tickets, the cost is irrelevant. So we won't need to include the money with this. We'll just say some adult tickets plus some student tickets totaled up to equal 8 tickets. All right, so these are your 2 equations. And now we're going to try to eliminate a variable. So since on the front I eliminated y twice, I'm going to work with x. I'm going to eliminate the x. And certainly I want to just try to get the same number, so a 7.25, but an opposite sign. So if I take my bottom equation and multiply it by negative 7.25, then I'll have the same number as my x in the money equation, but it will be the opposite sign. So that will be negative 7.25x and then negative 7.25y. And then I'll have to take 8 and multiply that by negative 7.25. And so you can use a calculator if you need to do that. And you will get negative 58. All right, and then we're going to add to that. And so I'm going to write this up above, my green equation, my money equation, 7.25x plus 5.50 or 550y equals, and then positive 52.75 or $52.75. So now I'm going to add my 2 equations. Notice that my x's cancel. So I'm taking 7.25, that's negative. I'm adding that to $5.50, and that equals, now it's a negative, so negative $1.75 or negative 1.75y. And then I'm taking negative 58, and I'm going to add to that $52.75. The 58's negative, so I'll get negative 5.25. And now to get my y value, I will have to divide. I'll divide by negative 1.75 on both sides. And notice that I'm dividing a negative by a negative, and that'll give me a positive. And that positive number is y equals 3. Remember, you can use Desmos to do this multiplication for you. So that's steps 1 and 2. We've now been able to solve for y. Now, I have y equals 3. I could substitute that y equals 3 into my equation that I've written in green, but that would be a lot of work. When instead, for my step 3, I just need to substitute into my bottom equation, which is much easier. Now, in order to keep my writing on the screen, I'm not going to move down to where it says step 3, but this actually is step 3. So I have x plus y equals 8. That is a much easier equation for me to substitute my 3 into. So I'll have x plus, and then I'm going to substitute 3 into the equation for the y, and then equals 8. And so now I can subtract 3 from both sides and get x equals, and then 8 minus 3 gives me 5. So I had to scroll and get this so that you could see the end of the problem. And so you can see that I substituted in for the y value in my equation for step 3. I have x plus y equals 8. I substituted in my y value of 3 in place of the y. And so I have x plus 3 equals 8. I'm subtracting 3 from both sides to get x equals 5. And I might add that this would certainly be the equation to choose and not the green money equation. You'd have a lot more work to do in that. So use your easier equation to substitute back into. And then finally, you have to answer the question that is asked. So the question that was asked is how many adult tickets were sold and how many student tickets were sold. So they purchased 5 adult tickets and 3 student tickets. And then that would be a good sentence answer to the question, identifying each type of ticket. So they purchased 5 adult tickets and 3 student tickets. So these are your examples. As you go through, be sure that you ask questions, and good luck on your homework.